So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says palindrome binary. The problem is pretty simple. We are given an integer n and we need to determine whether its binary representation forms a palindrome or not. So return true if it forms or else return false. And again, a binary representation is considered a palindrome if it reads the same forward and backward. So for example 17, the binary of 17 is this, and when I reversed it, when I read it backwards, it is 10001, and which is same as forward 10001. And yeah, that is why it is true. It is not the same for 16, and hence it is false. Well, you have seen, and yeah, they want us to solve it in log n time complexity and without using any auxiliary space. So cool. How can we proceed with this? Well, there are multiple ways to solve this one. So one such thing which can come directly within your mind is, hey, what if I can just take out each number, take out the binary representation, store as a string, then check palindrome. Yeah, this is good approach. This is a good approach, and it is okayish. It is acceptable, and yeah, you can do this. But there is one catch with this: you cannot able to showcase much of your bit skills or bit magic skills. This is doable. I'm not saying you cannot do this. This is obviously a simple category of problem, easy category, and this is the first thing which comes to your mind. It can be pretty much simple to you that hey, you can just take a binary, and it can be done in very one-line solution as well. Binary of n, convert it to a string, and it should be equal to string of binary of n dot reverse. Something very similar to this. And yeah, you'll get the solution like this. But no, we are not here for this. It is quite obvious, but we are here for another thing: how we can do it with using bit operations, bit ops. Because I think, I'm not very sure, I think that they want us to solve this with mathematics. Okay, cool. Mathematics, not similar to as bit operations. Okay, so how can we do this? So let's take an example of a simple example, rather 101, which is nothing but 5. So n equals to 5, which is 101. Now how can I solve this one? It means let's mark one of the one. Yeah, it is nothing, I'm just marking it 1. If you reverse this number, it should come it as 101 star. Yeah, it should come something like this. This one would be reversed here, although these both are identical, so it's a palindrome. But how can I solve this? Well, if you ask me for the solution, I would say that hey, I would pick one of the number, either from left or right. Let's take it right from. So this is right. Let me take one number from here, this one, and store it. Store it. So I'll call it as store. Yeah. Then once I'm done with this one, so I'll just mark it as done by done by a mere dollar, I would say. I don't know how to mark it as done then. And I'll proceed with next number, which is 0. So now store should have a place to accommodate 0. So this one, and it should have a place. So currently it is done over here, from here to here. Yeah. So this is 1. But now here should be a place to store 0, and I'll store 0 over here. how am I making a place? What do you mean by making a place? That's a good question. So this, consider this as like, yeah, it has only one bit like this, and this bit is just 1, but it has 2 bits, which is this position and this position, correct? And which means it is 1 0. So these are the position. So one cool technique to create a position is just to shift a bit. So if I'm having a bit 1 and I wanted to make place for next, then I wanted to shift a bit from 1, make place for 1 bit, okay, 1 bit, then I'll just shift it by 1. So this is a number, and I'm shifting it by 1. So what does it mean? It means that 1 is shifted and I have made a place for 1. Initially, if you don't assign anything, it is default to 0. So that's the concept of left shift, or I would say bitwise left shift. Cool. Cool. This is one thing. The moment I get 1 bit, I'll just store it over here, 0, and then I'll get to next bit, which is 1 star, which is 1 star. So in this way, I have reversed it. Similarly, if another number comes up is 1 0 1 1 0, then I would reverse it by, I will take first of all 0 0 2. I need to make one space for next incoming character. Next incoming character made space. Then add a number which is 1, because I'm going from left to right. So this is the character. So this is the character 1. Then I need to make a space, 0 1, make a space, because again I have few numbers pending. So next element is 1, and I have already made a space, so 0 1 1. And when I compare, 1 1 0 is not equal to 0 1 1, and that's how I come to know this is not a binary palindrome. With that thing keeps in mind, let's get started. Don't worry if you are unable to understand it right away, but please hold on, and once we start into code, things would be much more simpler. So this would be our reverse variable, which is integer. Initially I am assigning it to 0, and I'll also create a copy of this, what, n, because we will be going to manipulate n, and that's why we don't want to miss the copy of n. So I'm already creating a copy, and ultimately, as the palindrome says, we need to check whether reverse is exactly equal to the input original, or I'll say copy. So copy can be original, okay, I'll say original, ORM. So reverse is equal to original, then it's a binary. Cool, let's start to manipulate n. How long? So while n is greater than 0, we would be manipulating it, because we are removing 1 by 1 characters from the right. That would be our update condition. So this would be our update condition to remove numbers from right. And what would be our processing? Our processing would be make space for new bit in reverse, and then add a bit from n to reverse. That's it. So make a space, add a bit, make a space, add a bit, and that keeps on going until the loop ends. So make a space. How do I make a space? We have went through it earlier as well, by left shifting. So cool, let's left shift. Where do I make space? In n or in reverse? Well, I wanted to make space where I wanted to store. I wanted to store in reverse, so let's make space in reverse. So reverse is equal to reverse, left shift of 1. So I've made a space, add a bit. Now reverse needs to reverse, add a bit. How can I add? OR is an operation where you can add a bit directly, and I need to check whether it is 1 or 0. So how do I check? I need to get n ampersand 1. So if this condition is 1, that means the last bit of n was 1, and that's why I'm storing 1 here. If this condition, last bit of n was 0, then it was 0. It's easy and simple. Cool, I have made a place for a reverse as well. Next is update and remove numbers from right. So I need to update and remove numbers from right, so loop can end sometime. I don't want infinite loops, right? So n right shift to 1. Why I'm taking right shifts? Because again, I'm done with the last bit. Last bit can be get by ampersand 1. So this is a place where you can get the last bit. So I'll just say last bit getting via this. Yeah. And once you got it, I'll update n and things are smooth. Ultimately, I'm checking reverse and original are same or not. It compiles well. Cool. Let's see whether it runs for all the rest of the test cases or not. And yeah, it does. It was plain, easy, simple. The more important thing over there here is you have an ability to flex your skills in an interview when it comes to bit, because with bit the most important thing is, are you able to understand the placements or not, because bit operations are quite tricky sometimes, but once you understand it, you are going to nail the interview. Cool, that was all about it, and I hope I could make sense. This was a question asked in Amazon, Microsoft, Adobe, and for more such bit related content, click the video on your right, and I will see you in the next one.